Okay, so we're on section 2.12, page 241. And one thing I want to talk about is when solving equations, we're really undoing order of operations. So, for example, if I had like 2x plus 4, and you knew that x equals 3, the first thing you would do is sub this 3 in there, and you would do order of operations, which would mean you would multiply first and get the 6, and then you'd add that 4 in last and get your 10. So if I know what 2x plus 4 equals, say I know the answer is 10, then I'm going to do order of operations, but I have to do them in the reverse order and do the opposite thing to undo it. So to undo adding 4, I would subtract 4, and I'm doing it to both sides to keep it balanced, kind of like we talked about with chemistry. We want to keep it balanced. And then to undo multiplying what I multiply by 2, and to undo multiplying by 2, I'm going to divide by 2. And so then I can undo it and get my x equals 3, okay? So here, I have to think about what I'm undoing. There's no add or subtract here, so you could view it as undoing multiplying by a -1, because there's kind of an invisible -1 there. So to undo multiplying, I could divide both sides by -1 and get x equals a -7. And if you check your answer, the opposite of a -7 really is a +7, so that works. The other thing you could do on this one is just know what this is saying. This is saying the opposite of whatever x is 7. So when I take the opposite of x, I end up getting 7. So therefore, x must be a -7, so that when I take the opposite of it, I end up being positive. So that's another way to get that answer. Okay, over here, to get rid of, there's no add and subtract. So like if we're thinking of doing order of operations backwards, like parentheses, exponents, remember multiply and divide are on the same level, so left to right, and then add and subtract. So if we're going backwards, like we normally go this direction, but if we're going backwards, we're going to try to get rid of add and subtract. Notice this one doesn't have any. So now I'm going to get rid of multiply and divide. Now, if you want to, you are multiplying here. So you could divide on your calculator both sides by a -5/7. If you're doing that on your calculator, you got to group it so your calculator knows you're dividing by all of that fraction. So on your calculator, you could take 9, divide by, hit the divide by key, and then hit your little parentheses and then do your little fraction key, and it will work. I think it's probably easier to do the math yourself. So when we multiply fractions when we divide fractions, we multiply by the reciprocal. That's how we divide fractions. So if it were me, I'd probably just flip it myself. And again, when you flip something that's negative, it's still negative. So do you see how the 7s cancel, the 5s cancel, the negatives cancel, and then I'm just left with 1x, because 7 divided by 7 is 1, 5 divided by 5 is 1, negative times negative is positive, so I get a positive 1x. We just usually don't write it. Now, over here, you could put a 1 and multiply straight across, or do whatever you want, or at this point, you could use your calculator to multiply 9 and -7/5. That's up to you. You're going to get -63/5. So -63 over 5. And again, usually we don't write those as mixed numbers just because it's kind of a pain to check your answer. All right, so go ahead and try C and D on the next page. Okay, so both of these, again, if you think of, oopsie, just a second, I need to take a screenshot. I'll be right back. Okay, sorry about that. So if you think of, like please, excuse, so grouping symbols, exponents, okay, multiply and divide, and add and subtract. So normally we do order of operations this way, but if we're going backwards, we have to do the reverse thing in this order. So this definitely has adding in it by the x. So here's your variable, and you can say, oh yeah, there's adding there. So we're going to undo it. So what are we? We're taking 15 and adding it to x. So to get rid of a positive 15, we need to do a negative or subtract 15 from both sides. And again, that undoes that. Notice the x is still there. And debt makes more debt. And again, check your answer because it's easy to make mistakes. So if I put that answer back in, so I take this -23, and again, you can check it on your calculator. Just type 15 plus -23, enter, make sure it equals a -8. Because again, remember, it has to be balanced, okay, like a teeter-totter. Okay, now this one looks like you're subtracting a -6, and then it's like, well, what undoes that? Well, again, it's probably easier to add the opposite, so that you view that as just, +6, okay? Some people, when they see like this, they just make it a big positive because they kind of undo each other. All right, so I have this positive adding 6. So again, going backwards, I have adding, so I'm going to get rid of it. So to get rid of that, I'm going to add a -6 to both sides. And again, I want to keep it balanced. The whole thing is about, this is like a big teeter-totter, and the weight on this side has to be balanced with this. We can manipulate it. So like if this is 8 and 8, I could take 2 pounds off this side, make it 6, 2 pounds off this. But the bottom line is it has to be balanced. If I decide to double the weight on this side and make it 12, I can double the weight on this side as long as it stays 12. So on this side, I'm doing -6 to both sides. X equals 14, and I should be good to go. All right, so the whole concept here, and we'll use some algebra lab gear in class, is that you want to keep it balanced. So like on this side, I have this scale, and it's balanced, and so I could take 3 pounds away from both sides. So there's a box over here that's 3 pounds, another box at 8. So if I take 3 pounds away from both sides, notice what's going to happen. I'm keeping the weight balance. It's going to look different. This guy's just going to have a box, and this guy's going to have a box that's worth, what, 5 pounds? But again, I didn't change the fact that it's balanced. And then I know that that box weighs 5 pounds. So we'll do it a little bit differently in class. But turn to the bottom of page 243. You can read through the example they give you with the little balances, and then try to fill in the chart at the bottom of page 243. Okay. So what they're saying is operations done to X. So what are we doing to X? So pretend you know what X is, all right? I happen to know that X is really 2, but you might not know that. All right, so what happened if I knew X is 2? Well, the first thing I would do is I would shove the 2 in there, and I'd take 4 times 2, multiply first because of order of operations, and then later I'd add the 1 and get the answer of 9, okay? So that's what I do forward. So what's happening to X? I am multiplying by 4, and then after I get that answer, I am adding, oopsie, I don't know why I did that, adding 1. So if we're going to go backwards, right? So if first I'm multiplying by 4 and then I'm adding 1, if I'm going to undo it, I have to go backwards, but I also have to do the reverse thing. I can't keep doing what I did. So to get rid of adding 1, I am definitely going to have to subtract 1. So that would be subtract 1 from both sides. And that would get me to 4x equals 8, which is the answer that we had at that point for that value. And then to get rid of multiplying by 4, I would have to divide by 4. And so if I divide both sides by 4, I get back to x equals 2, which is what I started with. That's the first thing I did is sub in. So again, we're just undoing order of operations because we don't know some things. Now, what happens if we have x's on both sides? And we'll use the lab gear in class for this too. But say I have 2x plus 4 on one side and 4x, say, plus 2 on the other side. So what you have to notice is if you have any type of adding or subtracting the problem, then when you undo order of operation, you are at the adding and subtracting stage of life. So you have to start with this and work your way backwards. So the goal is this. I'll kind of draw a lab gear picture here. I have 2 of those blue X's, right? And then I have 4 yellow ones. So let's just shade these in blue. These are X's, right? And then I have 4 yellow ones. So 1, 2, 3, 4, and I will color those in yellow. Okay, and then on the other side, I have 4 X's. And again, blues are variables, yellows are constants. And then I have, let's see, 2 yellow ones. And so this is balanced, right? I mean, this teeter-totter is balanced. So then we want to think, okay, what can we do to solve this? Let me erase this a little bit. Okay, so we're going to do order of op backwards, but we kind of have both sides, and there's not just like equals and numbers, so we got a little more math to do here. But all right, so let's write what this equation is. We have it right here. 2x plus 4 equals 4x plus 2. So I have adding, so I'm going to have to undo it by subtracting. And so what I like to do is bring all of my blues, my variables to one side, all my numbers to the other. So since I already have 4 blue ones over here, I'm going to have this be my variable side where all my variables are going to live. And then all my constants are going to live on this side. So that means I have to move some things around, take some things away. So first of all, I notice that I have adding 2 here, so the opposite of that is subtracting 2. So if I subtract 2 from both sides, 2 constants, what's going to happen is these 2 yellow ones are going to go away, and so are 2 of these. And visually, because I'm taking away 2 yellows from this side, 2 yellows from that side. So I get 4x equals, and notice I still have what? 2x plus 2 on this side. Right, now, again, did I change the weight? Yeah, I changed the weight, but it's still balanced, right? So it's still, the teeter-totter is still balanced. Notice there's no adding left on this side, but there still is on this side. So I'm still on that adding and subtracting stage of life. So now I want to get my variables other to the other side. You don't really want the yellow constants mixing with the blue variables. So I want to get rid of these two x's over here. So again, notice I'm adding, and those two x's are positive. So to get rid of a positive 2x, I need a negative 2x. So I'm going to subtract, oops, I don't know what happened there, subtract 2 x's from both sides. All right, so these are going to cancel, and I'm going to get my 2 yellows there, and 4x minus 2x is 2x. And visually what's happening there is that I just took away 2 x's from this side, and I took away 2 x's from that side. And so you can see what's left. I have 2 x's equaling 2 of the yellow ones. Okay, now notice, is there any add or subtract anywhere in this problem? No, there is not. So that means we are moving on to the multiply divide stage of life. And again, we have to do the inverse to undo it. So to undo multiplying by 2, we are going to divide by 2, and x equals 1. If you think of it in terms of what you learned in elementary school, you have 2 x's that, like 2 friends that share $2. How much money does each friend have, or something like that? So what you're going to do is you're going to like kind of split these up. You're going to divide them in 2. So you're going to split it in 2 and say, okay, well, this pile, an x is worth 1. This pile, an x is worth 1. And that's why each x is worth 1. Now, check your answers. So shove it into this side, shove it into that side, and see if it's equal. So when I sub it in, 2 times, if I put a 1 right there, 2 times 1 is 2 plus 4, this side equals 6. And if I shove a 1 in there, 4 times 1 is 4 plus 2 is 6. So I know I'm right because it's balanced. All right, so go ahead and let's see what we're going to do. Try to read through example 1 and figure that out. And number 5, figure that out. And then, let's see, I'll catch up with you on page 247. We'll talk about 4 probably later, maybe in class or maybe in another video. So turn to page, read all the stuff in between here, and then I'll meet you on page 247. Okay, try solving 6A and B. There might be some weird stuff going on here, but just try, and we'll come back in a second. All right, so it's a good idea. You want to get all your kind of boxes in a pile, like all your X's in a pile, and then all your numbers in a pile, so that you can kind of tell what's going on here. Because your goal is to put the boxes on one side, the variables on one side, and then the numbers on the other. So if you notice on this side, it's not simplified. So it doesn't have like all the boxes together and all the numbers together, or all the variables together in numbers. So, and then same thing over here. We have 3x minus x. So what we're going to do is simplify both sides. So I have 3x minus x. I have 2x. Over here, if you distribute, 2 times x is 2x. And 2 times 1 is 2. And that 4 is kind of on its own. So I can go ahead and rewrite that as 2x equals 2x plus 6. So now I have all my x's kind of in a pile over here, all my x's, and then all my constants. So notice there's adding, but I don't really want to add the negative 6 to both sides to cancel because there's no numbers over here to put it with. So since the only place I have a constant is on this side, I'm going to leave my constants on that side, and I'm going to choose to bring my variables to the other side, because your goal is to have, you know, the yellow things, the constants on one side, the boxes or the variables on the other. So I am going to get rid of adding, but I'm using adding to get rid of this stuff. And again, if there's adding anywhere in the problem, you're still on this level. So to get rid of adding, I'm going to subtract 2x because it's positive. And notice what happens. Those go away. So I get 0 equals 6. So if I think of my balance, I have 2 x's over here. And those will be blue guys, so x and x. And then on the other side, I have 2 x's over here. And then I have, what, 6 yellow guys, so I'm just going to make dots here. So notice what happened. When I subtracted 2 x's from both sides to bring my variables over, they just went away. But it's saying that it's still balanced, and it's saying there's nothing on this side, but it's balanced with 6 things over here. And so when variables disappear, remember it's weird things. This is not true. So that is no solution. That's one of those contradiction things. All right, let's look at the next one. This one's going to be a weird one too. Simplify so we can see. Notice there's adding, so it doesn't matter. I might bring my numbers to the right, so maybe get rid of this guy. And so what do we get? 2x equals 2x plus 1. And then bring my variables to the other side. And again, see how they're still adding. So